All good? All right, thanks everyone. This is a Caliptra session. We're going to have 2 minutes of slides, 45 minutes of Q&A. That's the plan. So who do we have here? I'm Andres from Google.
Bryan Kelly from Microsoft.
Piotr Kwidzinski, AMD.
We also have Barun, who's going to come up to the stage for the Q&A. Hi, Barun, from NVIDIA. So what is Caliptra? We're just going to repeat what has been said several times. We talked about this in May, June, July, in the keynotes, et cetera, et cetera. So we have put out an OCP specification for a silicon root of trust block. It's not a chip. It's not something you put on your board. It's a block. It's logic, cryptographic assets, configuration, flows, ROM and firmware that you put in your SoC. The SoCs that we're targeting are SoCs and ASICs for what we do here at OCP market segment. Data center stuff. Not just CPUs, but in the fullness of time, GPUs, NICs, everything that touches users' data. Our goals here are implementation consistency, primarily and foremost. Implementation strength, of course. Implementation transparency, right? We're looking at an environment that is a little bit fragmented, and we're trying to see if we can bring everyone together to have a high quality, highly interoperable, highly reusable solution. This is a multi-party collaboration, obviously. Thank you for the great collaboration with Microsoft, AMD, and NVIDIA now. And this is not just a specification. We're going to talk about this a little bit more today. This is also open source. So stay tuned for the details that are going to be coming. I think we're the first security project specification proposing a technology block, but first by seconds. You know, the Tectagon guys, et cetera, and foremost, we are work in progress, right? We're not coming here, we're 1.0, ready to go, GA, you know. We're not cutting ribbons with scissors. We still have work to do. So news for this, I mean, this is probably all news by now. The Caliptra specification got released on the 18th. It's a specification 0.5. Why is it a 0.5? We don't believe our work is done to get to our 1.0 in the way that we want. There's a couple of things here that are going on. The current 0.5 talks about a passive specification. This is what you do if you have a legacy SoC and you have your boot flows figured out and all of that. So in this scenario, you drop Caliptra in, and it operates as your source of identity, your root of trust for identity, and your root of trust for measurement. That's the scope of Caliptra. We're keeping this scope very focused so that we can have a good basis for interoperability, transparency, and high quality. So Caliptra is in charge of identity, is in charge of DICE, is in charge of attestation, is in charge of measurement. We're going to follow relatively soon with another step of the specification. We are relying quite a bit on TCG DPE. TCG DPE is something that we can begin to talk about now, but TCG has not finalized it. So once they do, we're going to pick up the pieces that we're interested about and that we're driving over there. We're going to make it obvious in the specification what happens. And we're targeting a 1.0. Somewhere around February, March, April 2023. And the 1.0, we expect to be code complete. We expect to be specification complete with all the details. And what we call, for lack of a better name, an active integration, which is when Caliptra is booting your SoC, which is a lot easier to do with first generation SoCs, of course. So that's the current trajectory, right? That's what we're presenting today. It's open, you can read it. And that's where we're going to go. Partners, we started Caliptra 6 months ago, at least officially, time before that. With Google, Microsoft, and AMD. We're welcoming NVIDIA today. We're super excited about that partnership and the reach that Caliptra can have and the quality that Caliptra can have, both in integrating the expertise of the NVIDIA folks and the product lines there. So in terms of code, and this is going to be my last slide, and I will hand off to my colleagues. This is heavily work in progress, and we just want to be very specific that it encompasses a number of things. It's RTL, of course. Piotr will talk about the RTL. You know, there's a RISC-V core because you need logic. There are cryptos because we're doing attestation and measurement. And of course, there's a lot of glue and mailboxes and all that stuff. But there's also firmware, right? The boot ROM of Caliptra is critical to the DICE flow and of the whole SoC. And there is mutable code, and there's, of course, an emulator. So we're very early on. This is the message that we wanted to give you. We wanted to give you a message of the intended scope. It is ambitious, but please be patient. We're very early on. So the next slide is I'm handing over to Bryan.
Thanks, Andreas. And the code is probably the easy part in my view. It's the governance and setting up the project for success. So there's a joint collaboration that's been between OCP and CHIPS Alliance to support Caliptra, and that's really to get the right community structure involved. We said OCP is where a lot of stuff comes together. It's the water cooler or the watering hole where a lot of systems and system level specifications come together. But when we want to drive community around contribution to stuff in design, what we've seen with software projects in Linux Foundation, we've seen that community support there. So what we've put into OCP is the composable architecture. Last year we spoke about the role of the rooted thrust for measurement inside SoCs, and we've now published the Caliptra specification at a 0.5, and we'll follow that up with a 0.8 and then the 1.0 early next year. So CHIPS Alliance has many open source RTL projects and DV sub-projects today. So we looked at the structure there and looked at that being a good home for Caliptra. Caliptra will be a sub-project. We'll have the RTL and the firmware housed over there. And then we'll have the specifications as they evolve. We'll put those into Open Compute. CHIPS Alliance, a little bit about it if you're not aware, is it's a directed fund in the Linux Foundation. The license that Caliptra is being licensed under is the Apache 2.0. Okay, a little bit on the governance. This is like the part that's still work in progress too, and how we get it set up and how we get the repository set up, but also getting the right governance in place. In CHIPS Alliance, there is a draft that we've been working on how we like that to ensure that all are welcome to contribute into Caliptra. That means that they can do git pulls and git commits, but on top of that, there's normally like a technical steering committee that is really responsible for the commit approvals and the merges into the main branch and making sure that the quality is upheld as we take different contributions. So the technical steering committee is, of course, initially made up of the 4 founding members on Caliptra. But of course, we're putting in the governance that the voting for additional members onto the technical steering committee, vote around how the mark should be used for Caliptra, and any charter modifications or substantial changes to the initial charter and scope for Caliptra. So there is a Caliptra mark to legitimize, I guess, Caliptra instantiations. When the code is out there, anyone can clone, take downstream, synthesize it, add to it, and modify it however they wish with the regular rules of Apache 2.0. But of course, then what instantiates an actual Caliptra and the Caliptra brand? And we're working on the acceptance criteria for what is a Caliptra, and then what is a Caliptra derivative, and what we would do around conformance and automating that to make sure it's hassle-free. That's all work that's currently going on in the Caliptra consortium. And with that, I'm going to hand you over to Piotr from AMD. He's going to go through a little bit about the RTL and firmware on Caliptra.
Yep. Thanks, Bryan. Okay, so as Anders said, we've been presenting some of those components before in OCP, but let's quickly recap the actual components that makes Caliptra. So As Andres mentioned before, we are really trying to be narrowly focused on providing the basis for Silicon Root of Trust by building on existing standards, either OCP or TCG. And for attestation, obviously you need an identity for the device. And for that, we are aligning with TCG dice specification as a primary identity for the device. And Caliptra is responsible to measure all the mutable code and manage those measurements as device boot, and then provide tracking of the device life cycle and security states. Now, in terms of ownership, we are actually looking at no stateless transfer of ownership. So there is no provisioning into the fuses of new ownerships. Instead, we are looking at providing a way to do a runtime owner authorization flows. And details are still being worked out, but you can take a look at the specification on our initial thoughts on how that can be achieved. And then for attestation, again, we are aligning with TCG, DPE. Now we can start talking about it more details. So the current specification, 0.5, do not have those flows defined yet, mainly because we were waiting for TCG to publish DPE spec before we can actually make it public in our specification. So now Andres mentioned about this active and passive mode of integration for Caliptra, depending on how you approach your SoC boot path. Really, the key point here is that with all the legacy existing products that already have secure boot and managing the attestation, we are providing a way, and that is really the main implementation that we are currently detailing in the specification, where there is still legacy SoC secure boot, and Caliptra is aligning into those existing flows, and those are described in the integration specification, how that can be achieved. And then going forward, we will also provide a way to do the active, where Caliptra is fully owning the boot path. Okay, so a little bit of about dice identity and how we build this in the Caliptra boot flow. A couple things I wanted to point out here that are a little bit customized from your regular dice flow is that aside from the regular unique device secrets that is provisioned in the manufacturing, we are also adding what we call the field entropy, which is a way to rotate the seed of entropy for identity, and that can be added by owners of the device after they are manufactured, right? So they can be updated in field basically, and that entropy will be included in the initial CDI for DICE LDEV ID certificate creation. And then also all the measurements, obviously for regular DICE flow, will be added in each level of the DICE as we boot and authenticate and measure the firmware components. Okay. So this is might be a little blurry, but this is the current block diagram of the actual Caliptra hardware. So it's built around the RISC-V microcontroller. It has all the regular internal buses, and we have a crypto subsystem with crypto accelerator for all those authorization measurements and identity purposes. And then we have a glue logic and interface into the SoC. And this is something that we are trying to make as narrowed and as simple as possible, so it doesn't require a lot of glue logic around Caliptra to actually integrate it into various different SoCs. So we are defining a single entry point really to communicate with Caliptra with a mailbox interface and a set of reset signals. And that would be one and only way really to communicate between Caliptra and other SoC components. And as Bryan mentioned, we are currently working on all those governance documents and actually the technical aspect of hosting all the code. But the code is already running in emulation, so we are encouraging everyone to go and see the demo in Microsoft booth. This is the actual code that you can, implementation of the actual design that you see here running in emulation live. So I don't know if we have a specific date yet on availability, but that should be within the next couple months or so.
Yep, for sure.
Yep. Oh.
So we'll invite Barun to come up if you want for the Q&A section. We're entering the Q&A. Thank you, Piotr.
Thank you.
Just to reiterate, the call to action is provide input to the spec, which is available now. And as soon as the RTL and firmware are up, we welcome any and all contributions. Stay tuned for that. And of course, consider integrating Caliptra into your SoC once we have code to show you and you can marvel at it. Anyway, so we're into the Q&A section. Thank you for listening. Thank you very much for attending. Thank you for coming to OCP, of course. And we now have probably 20 minutes to take questions. Thanks so much.
In terms of the hosting or the actual membership or to the Caliptra, the governance, will this be hosted under OCP or will independently? How will that be done, and will you anticipate a cost to be a member of the project?
Cost? No. If I heard you correctly, cost? No cost.
No cost.
We will be hosting in CHIPS, right, which is a directed fund of the Linux Foundation. That's where the code will be hosted. And that extends to verification tools, emulation, ROM, firmware, RTL. As Bryan mentioned, right, we know, I think we can say with confidence, we know exactly what the governance is. We have all of our lawyers and open source specialists drafting up the documents so that we can get there as soon as possible.
How soon will that be open for, or do you anticipate for other new members?
Tomorrow, yesterday, but we need to draft up the documents and people need to sign them up, right? We need to have good rules of engagement. Okay. All the good intentions are there. We just want to be very methodical and careful to where we get. I would say 2 months, which is what Piotr mentioned. I think that's a reasonable estimate.
Just one other question, then I'll sit down. Today, are you leveraging fuses for storing the unique device secret? Are you looking or going to leave an avenue open for leveraging other methods like PUF, for example, to be able to drive the secret?
I can take that, but does somebody want to take it?
Yeah. You want to tell
me? Yeah, definitely. So as you saw in this block diagram, we have the glue logic around it, and actually Caliptra do not implement fuses itself, right? Instead, because of the various technologies for different products, different vendors, we decided to have fuses outside of the Caliptra itself. So you can use, eFuse, you can use PAF potentially if you have that implementation.
So to complement that answer, right? Caliptra is not in the business of defining fuse technologies or which fuse technology is the true fuse technology. Each individual vendor and supplier will do what they do. They have their own technologies. That's why Caliptra obfuscates the assets. And then we can talk about how to obfuscate it, right? Whether they are class secrets or RTLs. Another reason that we have this field entropy, and this is born out of observations that we're doing here in OCP, right? Maybe some fuses technologies are more impervious than others, but there are some that are not particularly impervious. So we regard the supply chain as a place where adversaries have a very long time to extract that UDS. So that's why non-destructively, right? In a way that you would not be able to tell. So that's why we're adding this step of field entropy to top up the entropy after the supply chain has been traversed.
So just to add to that, there are wrappers for the analog components, and everything that's ingested is then further obfuscated or derived cryptographically.
So I know a few years ago there was the Open Titan project, which as I understand it was RTL for external roots of trust. Is there any conceptual relationship or anything similar that this is a pretty new separate concept in tech?
Do you want to take it? I'm joking.
I can try.
So the Open Titan team is here, and we're very happy, right? And we work together, right? I mean, we work together all the time. I think, so let's rewind to something that we said 1 year ago, right? 1 year ago, we came here to OCP, and we talked about admissible architectures, right? And that's a presentation that we did with 5 partners at the time. And we talk about looking at NIST 800-183 and looking into those pillars and kind of separating things, right? So Caliptra is a root of trust for measurement. It's our confidentiality. It's about I'm running the code I'm supposed to be running. And we believe given supply chain, given interposition, given all these kinds of threats, given edge, given confidential compute, given all these trends, we need to put this in the SOC, right? And I will speak very carefully here. Cyrus is over there.
I stepped in the middle of go right in the middle of the crossfire. For
yeah. But where Open Titan, I believe, is right now, is they're producing a standalone chip, right? A standalone chip that you put on your board. And they're looking for certifications, and they're looking for multiple market segments, and so on. And that, in our view, is useful to address, among other things, the other 2 pillars, the availability pillars of 800-183, which is platform root of trust, check updates, perform recovery. You have an external reference monitor outside of all your SOCs in order to do that. That's Google's data center team's answer.
Okay.
Thank you.
Thank you.
Is that good? Okay. All right, I'll amplify that because Cyrus doesn't have a mic. Open Titan is starting an integrated working group.
Yeah, my question's around the IP that's in the crypto blocks. Is that all new development? How's it been certified? How's it been tested? And has there been searches to make sure that it's not violating other people's IP? Because I know IP is a big thing in the. You guys may have covered this already, but.
Yeah, and I can answer that one. So it is all new. It's a new base. The crypto, as we said, we're early, so it's going through all of the verification and the testing that's necessary on that. So as I said, we're still early, but we're moving at lightning speed. If you could go and look at the demo that's out there, there will be additional specifications to talk about the things like countermeasures and that are implemented, and we're being very transparent in those. It's not about security through obscurity, but letting these countermeasures stand on their own merit.
I think one thing, right? It's not all new, right? We're using an Apache 2.0 license RISC-V core. Once Apache, always Apache.
Yeah, that portion of it,
Yeah.
RISC-V for sure. Yeah, it was really more around the crypto blocks because a lot of people purchase that IP and put it in their silicon. So if someone were to go use this block instead, that was sort of the question: is there concerns about royalties and certification and all that kind of
No,
stuff?
it's Apache.
No,
It's
Apache
Apache
All
2.0.
Apache, and then the plan is to take it through certification at some point, like NIST
Yeah.
or
We're early certification. If you've gone through it before, that process takes time. There's a long queue, but we're in the queue.
okay. Thank you.
And since this might go into devices running at very different frequency ranges, like 200 megahertz, gigahertz, is the implementation targeting a particular frequency, or is the expectation that the adopter takes it and tunes it to the right frequency?
Yeah, that's a great question. The adopter, there's always some tweaking on that. We have taken it up, high in frequency already and pushed the boundaries on that. So we'll have some guidelines as to where it's been validated at.
Just to add, right, we are not really intending to run any time-sensitive critical code, right? So the frequency shouldn't be that important, right, to provide the components for identity and measurements, right?
Yeah, that's a great. I'll just add to that. It's not a data pod accelerator. It's a root of trust. We're not targeting, the 200 gigabit, 400 gigabit line rate AES in this. It's so much smaller.
Having done this, Piotr, before, where we tried to move it to a different IP, there were a lot of problems. So.
Yeah.
Yeah, there will be some guidelines, right, where we validate the range, right, where our code can reside. But I think the goal is to be really as flexible as possible, and that's just one aspect, right? But also, as I mentioned, the whole interfacing to other SoC components, we are trying to minimize it such that it's easy to integrate, basically, and that's the goal.
Appreciate that. You spoke about RISC-V over here. So do we have to necessarily integrate it into our silicon RISC-V itself, or can the RTL be ported to our existing secure enclave processors? So one thing being that, and then I would assume the spec will have a list of entities which are offered in the silicon, do we offer TRNG and the crypto accelerators you do? So I'm sure we will be having a list of those entities in the spec and those APIs which we can use to interface, example, to our SpyNOR, like to read the firmware image and validate the signatures.
So there's a lot of questions baked into that one.
Yeah.
Thank you. It's a spec and code, right? It's spec and code, right? So I have my favorite CPU and I'm going to throw away the RISC-V. You can do whatever you want in downstream, but going back to one of the governance things, the code is meant to provide the transparent and consistent implementation, and that's the spirit of what we're doing. You asked several other questions. One of them was about SPI. I don't know.
Yeah, I can think. Again, this comes back to this, making it easy for integrate, right? So we are looking at, things like fuses, things like your boot media, right? Those are not things that we necessarily want to put inside Caliptra. Instead, there will be flexibility of how vendors attach those interfaces into Caliptra, right? And then through the mailbox, that's where we are defining how we communicate with the rest of the SoC. With SPI specifically, we were initially looking to have SPI controller inside Caliptra, and that would depend on this active versus passive mode of operation, really. For passive, Caliptra gonna rely on some other entity within SoC to provide access to the boot media, right? For active, yes, there might be a specific controller, but I think we also have a way to do it such that vendor can actually decide what is my boot media and how I provide the firmware image into Caliptra, right?
No, the intention. So the gentleman here wanted to emphasize the first question about using RISC-V. We're looking for consistency, right? So this is the code that we're putting out. Yes. And RISC-V is, this is pretty obvious, right? It's the thing everybody can license and do Apache 2.0, et cetera, et cetera. So that's the advantage that we're exploiting. Julian.
Thank you for the presentation and bringing this to OCP. Last year, you guys spoke about solving the problem for RTM, and today we have something, which is great speed. So thank you for that. One thing I wanted to understand more clearly is we have PDOT in the DCSCM module, and we have an IROT on the CPU, or any SoC that you want. Do we plan to also standardize the interface and the rules and responsibilities between the two?
I don't think we need to standardize the interface. There's SPDM, there's TCG at the MTF, there's TCG DPE. The prior presentation was talking about how a block like Caliptra would talk to an external EA-ROT or a TPM. Those exist. I don't think OCP needs to go and reinvent those wheels. This is my opinion, right? There are other people here. I think we do owe the community let's put it all together document for sure. But I don't think we need to reinvent those wheels. I don't know if anybody else wants to say something.
Aaron, you have talked about attestation, right? So.
Yeah. Next talk will be about how we integrate attestation in terms of, going all the way from the dice layers to SPDM implementation. And yeah, those are all the pieces connecting these dots. And we hope to leverage that work in Caliptra as well.
Correct. I mean, we do have specifications that talk about how the protocol should work and what are the standard primitives that we can use, but a reference implementation similar to Caliptra. Sorry.
No, so again, right, the scope for Caliptra is really to provide the identity, to authenticate the device, and collect the measurements, right, and provide them as evidence of what we booted, right? And you can use it in different flows, right? Like Andres mentioned, right? This TPM authorization is one of the usage where it's not it doesn't have to be driven from Caliptra, right? Caliptra exposed the identity and measurements, and through DPE extend it into host, and then you can run additional usages there, right? So we don't necessarily specify all of the platform level protocols for Caliptra. We are providing the ingredients for the SoC to have a identity that you can authorize and all the measurements, right, that verify what has booted on this SoC. And then how you use it at platform level, again, SPDM is well defined, one of the usage, right? The active TPM or protected TPM, I guess, is another usage. And I'm sure there will be some additional usages specific to different platforms, right?
I think we're moving methodically and deliberately, right? So this is one step, right? There's a lot of vendors of everything, right? I think we're seeing some very good signals here. You saw the Tectagon presentation. There is OpenTitan, right? So there are different parts of the platform that are coming together in open source manner. Right now, this is our focus, right? This is where we're putting the wood behind the arrow.
We have reference implementations of that. We don't need to, again, do that. Caliptra, we didn't have anything before that, and that's the reason we're trying to solve that.
Yeah. Yep.
Thank you.
Yeah, thank you for the question.
Okay. First of all, congratulations. I think you guys have done a great job, and it's really great to see the efforts on putting together a DPE interface attestation integrated in a nice API in an open source way. So based on my understanding, Caliptra is a spec and is also an implementation. So you're expecting to see integrators use the RTL, right, to be Caliptra mark compliant. My question is, would you guys be also open to support a Caliptra API as an option as well for other use cases? Because having a DPE interface with attestation can be very useful for other markets. So something that I would be very interested in using as well.
You mean consumer? Like non-server stuff? Yeah, I mean, I don't know if somebody wants to take that, right? I mean,
Yeah, I think this goes to the pattern of the nesting dolls here, where TCG will be defining a DP interface, and folks are welcome to implement that interface. Caliptra is providing a reference implementation of DPE from firmware through hardware, and that'll be used for particular use cases like the talk that Jeff, Jordan, and Ahmed gave this morning. And so, yeah, those pieces will be there, but Caliptra is defining the specification for building that in this data center environment. It doesn't imply that nobody else can build another DPE implementation.
But are you guys open to considering also Caliptra as an API?
But are you asking about specifically if you can
Call DPE.
implement DPE and just call it Caliptra?
Look at the spec, implement the spec, and then there's already an API, right? If I am compliant to the hardware spec and the API spec, can that be called Caliptra as well?
So DPE and Caliptra are not equal. Like, yeah, Caliptra implements a DPE. It also, if you look at TDISP and PCIe IDE, it also has an SPDM flavor to it. So calling a DPE implementation Caliptra is not the goal. The goal for Caliptra is to have transparency and consistency of the root of trust.
Okay.
So if you can achieve that, we're Caliptra compliant.
Okay, awesome. Thank you.
I think, so 3 minutes, so we'll take the gentleman's question.
Yes, I had a similar question. So I understand that you have a spec and an implementation of your RTL that will be, is already available or will be soon available. The question is for vendors that already have implementations that could be modified in terms of software interfaces to comply with exactly the same services as Caliptra. Is that an eligible product to claim compliance, or is the RTL implementation mandated?
So from the top, the reason why this collaboration is succeeding between Google and Microsoft and our partners, AMD and NVIDIA, is that it takes a phenomenal amount of time to debug and integrate the great variance of implementations out there with very different quality and very different security or non-security, right? I'm pointing any fingers, it's reality, we all know what it is. So again, the goal here is to get a consistent implementation across the board.
Okay, so will it be fair to say that there is an attempt to avoid to get into some kind of integration compliance test bench program that will be a bit too heavy and more rely on the implementation to give that transparency and guarantees of behavior?
Yeah, I think we don't want to be FIPS or NIST. We don't want to become NIST. We're not set up for that, for sure. One of the big opens, it's the last bullet point actually on this slide, right? One of the big opens is how we're going to put together acceptance testing criteria. We're thinking about that, but we're at the beginning of the road.
Okay. Will their last question, will there be, because various SOCs come with various requirements, frequencies, nodes, clock domains, things like that. So everybody will have their own integrations challenges, right? So how will that be? Do you have an idea how that will be handled?
Well, there's the project of Caliptra in the open source, and then there's the product of Caliptra as what you've integrated it into. And we've guidelines on the integration and where it's been validated to. I believe Balaji asked the question earlier around the frequencies that it's been validated at, and we'll publish those in that range, and then as you take it out of that range, if needed. then that validation will be done in the product.
Okay.
Yeah.
All right.
So basically,
So sorry, it's 11. There's another talk. They need to set up AV and everything else. We're here. We'll take more questions offline.
We'll be around.
Thank you.
Yep.
Thank you.